All right, here we go. 8.2, cube and cube root function transformations. Let's get it started. So, guys, cube function. So we've talked about it before. We have A, B, C, and D that affects our function. So here we have f of x equals A times B, x minus C to the third plus D. Okay. Now remembering from our previous thing, what everything tells us. A tells us how to stretch, compress, or reflect, right? You remember that? A, it's the same as all year long, so we're going to go through this fairly quickly, right? B tells us how much to stretch, compress, but horizontally. C tells us if we're going, if it's a horizontal shift, so whether we're going left, right, up, or down. And D tells us how to shift vertically, so whether we're going up and down. I didn't mean to say that for C, okay? So key things to remember, that's what each variable represents. Yes?
Yeah.
Has it changed at any point this year?
No.
No, it has not. So let's dive deeper in to examples with the function. Bam, here we go. So when you're talking about a cube function, you have x to the third plus d. If d is greater than 0, meaning that it's positive, you're going to go up because that means you're adding to your y values. You remember that? So we're adding to our y values, going to shift us up. If d is less than 0, that means you have a negative value. And that means that we are subtracting from our y values. Remember that? All right, questions about D, our vertical transformation?
No.
No? Okay. All right, now we're going to move on to C, okay? The key thing to remember here is that if C is by itself, then it is what it is. If there's a B, then there's a little more we have to do with the C. I'm going to probably leave that for your pre-cal teacher to worry about. I'm not going to worry about it. So we're going to just continue with C. What do we need to remember about our X's? X's are what? Liars. Okay. So our C, it looks like a negative, but it's actually a positive. And when it's a positive, that's going to shift it to the right. So that means we're adding to our X values. Okay. So we're adding to our X values means we're shifting to the right. Okay. Again, our C is negative. It's going to cause us to shift to the left. So we're subtracting from our X's. Okay. And again, it's the opposite of what it looks like. So it's going to look like a negative C and it's going to look like a positive C, but they are what? Liars. All right. Our stretch and compression and reflection. Okay. So when you have a vertical stretch, so if your A value is greater than 1, notice that we're focused on the absolute value of A, so not paying attention to whether it's negative, but if it's greater than 1, that's a vertical stretch along. So we're getting skinny, we're working out more, so we're stretching out, okay? Now, if we stop working out so much, my life, that what happens is you get, you compress, you get wider instead of skinny, okay? That's what's happening here, all right? And then our A is less than 0, which means that we're working with a negative. If it's negative, then that is a reflection over the x-axis. So we reflect over the x-axis. What's happening here is that if we're at xy, when we reflect over the x-axis, it's going to become x comma negative y. I'm going to tell you. You ready? All right. So B is our horizontal compression. You know the accordion, is it an accordion? What's the thing that goes? Right, the accordion. So when you have the accordion, you compress it. The more pressure it's shrinking in, right? If I compress in on the accordion, it gets shorter, correct? That's what B is saying. If I press inward horizontally, it's going to shrink. It's going to get shorter, okay? But if I stretch it, think about the accordion. I don't compress so much. I stretch it. It's going to get wider. It takes longer to expand. That's what B is doing. B is your accordion effect. You're going in and out. More pressure, compressing it is going to shrink it. Not compressing and releasing pressure is going to stretch. Okay. That's what the B value does. Okay. We don't really see the effects of the B value until you get to a cube root. We haven't had to have really any B value effect because the other functions we've been working with they're horizontal and vertical compressions almost work the same. All right. Now, so if your B is negative, what happens is that you used to be X, Y, but then you're going to reflect and it becomes negative X and positive Y. Okay. Now, we have this chart in our notes also for the cube root, but we're not going to rewrite the same stuff. Does that make sense? All these little things we've written here is going to also apply to the cube root. So questions, comments, or concerns? No. All right. So only thing I need to write left is your A. A affects, what did A affect? Y. This affects, is it A or E affects? Which A? Which one do I use, guys? I use A. Do I use the A? Affects Y. And this one affects X. So if you look at how it changed, our X has changed. Did our Y change? No, our X changed. I don't know. I hate using.
And then E is like cause and effect. Yeah. Cause and effect. Well,
I don't know.
Alicia, how are you gonna back this up and say I don't know?
I was honest and told you I didn't know. So we're gonna continue.
Christian, you made up a word.
All right, here we go. So we're going to describe the transformations. Okay. At this point, we should be able to describe a transformation without looking at a graph, right? You can still look at the graph, but should we be able to describe it without looking at a graph?
Yeah.
Yes. So here, which variable am I getting? A, B, C, or D? I'm given my B, and B equals -2. So that means what happened to the function? Huh? It was a, what did you, it's an E? I should have wrote E. Oh, dang it. Oh, I'll go back. All right, it's a horizontal stretch. Remember, it's different. It's the opposite. Compressed means it's less than. Wait, did I write that right? I like shrink. It is compressed. Horizontal can shrink. I don't know why I'm tripping over here. This E business got me lost. So it's E for real?
Yes.
Oh man, stop switching on me. It's a horizontal compression by 2. And then what does the negative tell me? Reflect over which axis though? The Y. So we have a horizontal compression and a reflection over the Y axis. So the B is going to change your X's. So the B changes your X's from being positive or negative. Where it's located. So if it's inside with the X, that's a B. If it's on the outside of the parentheses, it's an A. So right here, this is inside, but if there was a number on the outside. Yes. Twin. 2. What variable is given? What variable is given? It's a B, right? And so with B, we have equals -½ So this time, what do we have? A horizontal stretch by 1/2, which means I'm applying half the pressure, right? I'm not compressing it as much, so it's getting longer. And then what else? It's a reflection over the Y. Okay, because that means our X values are changing, right? Not our Y values, but our. All right, here we go. What variable is given here? A, B, C, or D? D, and D equals -4. And what does that mean we have? Shift down. It's a vertical shift down. Is it all right if I just write V shift?
V shift down.
All right, how do we feel so far? Easy. So these are examples of single transformations, right? Now we're going to look at examples of also single, but then a couple of multiple. All right, so example 4, what variable am I given? C. So C equals, and our X is a, so it's not a +4, it's actually a -4. So C equals -4, which means I did what?
left.
I went to the left, so horizontal shift to the left. All right.
And then you get to HT.
Shh.
Bro, Chris,
On number 5, what's happening?
D,
And what else?
and reflection.
I have a B and a D, right? B equals -1, Casper the friendly one. And D equals 3. So what are the transformations that are taking place? So we're going up 3 and reflect across the Y. There we go. I don't know what's going on with my pen. All right, good. All right, 6, what's happening? What variables are we given? We have A, which is 3, and we have C, which is +4. And so what's happening? What are our transformations? There you go. Vertical stretch by 3. And we went right 4. How do you feel about being able to describe a transformation without its graph? Doable?
Yeah.
Just took us all year to get here. All right, cube root function. I don't know why I also have my both functions on here at the same time.
Oh. So this up here was for this back then.
So you should be on the back now or something. I hope. I don't know how I did. So on the cube root function, are the A, B, C, and D doing different things? No. Because has A, B, C, D changed us at all this year? No, it has not. Okay. All right. Same transformations, same rules. Only thing is different is the shape of our function, right? Questions so far? Are we ready to describe? All right. So let's jump in. Huh? Oh, don't ask him that. All right. On number 1, which variable am I given? A, B, C, or D? D. We have D equals 5. What does that mean? We go up 5. Perfect. On 2, what variable am I given? B. And what does that mean? Horizontal compression. On 3, what am I given? Your A. And your A equals -2/3. Ooh, what does that mean is happening? We have a reflection across what though?
The X.
The X. And we have what? A compression. It's a vertical stretch. I mean, a vertical compression. I didn't mean to say stretch. It's A. So when it's 2/3, you're going inward.
Oh, okay.
So it's a vertical compression. A V compression or shrink. Because 2/3 is less than 1, right? All right, good.
Yeah.
All right, let's finish it out. On 4, what variables do I have? I have D and A. We have A equals -1 and D equals +1. So what's happening to this function? Perfect. Reflection. I don't know why I can't spell. Reflection. Across x-axis, and we went up 1. All right. 5, what do we have? C, and what is our C? -5. Our X is a liar, and our D is? So what happened? We went left 5, and we went down 2. Perfect. All right, last one. What do we have? We have an A and what is our C? Positive 7, because our X's are liars. All right, so what happened? Good job. Mm-mm.
That's not it.
Oh, right.
No, wait.
It's a C. Mhm. What else did the A do though?
Vertical.
Vertical stretch. And then we went to the right. 7. If you leave this class knowing nothing, hopefully you know how to read a transformation.
And wait,
All right.
on both of these, or just-
Yeah. All right. So your classwork will be on Canvas.